Hello. Hello. All of you, please mute yourself first. Don't try to create any type of the disturbance. Number 42. Please, number 42. Please mute yourself. Number 13 also. Please check once.
Sir, Ganesh sir.
Yes, sir.
Ganesh sir.
Yes, sir. Yes, sir.
Okay, sir. Audible, sir.
Okay, sir. Thank you, sir.
Hmm.
So let us wait 1 minute to join some other
Okay, sir.
members.
Okay, sir. Okay, sir.
Okay, sir. Srinivas, sir. Sir,
Sir, చెప్పండి.
may I start my session, sir?
Yes, sir.
Okay,
Start
sir.
చేయండి.
Thank you, sir. Thank you, sir. Good afternoon, everybody. I hope I am audible to everyone. Up to now, only some of the members only joined in our group. So, try to start our class. In the last class, we are discussing about some of the important topics in the second unit. So, those are the first one is the architecture evaluation, and the second one is we are discussing about ADAM, and we are discussing about okay, class we try to discuss about the second part of the second unit. Okay, we are already discussing about the part one of the second unit, that is analyzing architectures. So that means here we are analyzing the architectures means nothing but we are performing some analysis on the architectures. Am I right or not? So that means what we are, which thing we are to be analyzed here. So that means whether the software architecture is able to performing the functions properly or not. So whether it will be meets to the desired goals or not. So all these are verified in the case of analyzing architectures. So in the case of analyzing architectures, we are discussing about the three topics. So they are, the first one is the architecture evaluation and architecture design decision. And second thing is the method, one of the best method to analyze the architectures are performing the architecture evaluation efficiently. So for that purpose, we are using two methods. Though they are nothing but ATAM, and another one is the CBAM. So ATAM means smart architecture trade-off analysis method. CBAM means cost and benefit analysis method. I think the name is implies for which purpose these two are using. So in the case of architecture evaluation, we are performing the evaluation on the architecture. So whether it will be performed efficiently or not, whether it will be maintained out of the scope or not. So whether we are facing any type of the problems. So how much of quality attributes we are achieved and which are pending. So all these are verified through the evaluation. So all these topics are we are discussed in the last class. So in this class, we try to discussing about the another part, that is moving from one system to many. So before going to that topic, we try to revise the previous topics within the short way. So in the case of architecture evaluation, mainly we are focused on the 6 types of inspections. So that means when we are evaluating some architecture, or maybe how we are analyzing the architecture means some based upon some type of criteria. So here we are considered 6 type of criteria here. So those are, first one is the financial. So that means before developing any type of the software, developers should be having the idea about that software that software budget. So how much of time is needed, how many number of peoples are needed, and how many number of days are needed, and how much of amount is needed to developing this software. In some type of situations, maybe it will be out of the scope. So architects should be uh, having the clear plan. So how much of amount is needed to develop this architecture. So that is the first thing, financial way. So that means whether we are planned our developed architecture within the our plan or not. So that will be discussed here. And another thing, forced preparation for the review. So that means, for example, maybe that project needs, maybe that software development needs maybe 6 months. So in that 6 months, we try to arrange at least 6 reviews. So that means at each and every time of the review, we are collecting some status about that particular software architecture. So that means how much of quality attributes are we are achieved, or maybe how many number of modules are completed. So in this way, here we try to arranging reviews. So these reviews are used for to provide easier interaction with the users at the same time. So those reviews are used for avoiding the conflicts or maybe misunderstanding between the developers. So why? Because all these members having the same idea, same goal to complete that software. So if you are arranging the reviews like this, then remaining developers or maybe the remaining architects may be having the same idea. Okay, and and they know about how to work and where to work and how much of effort is needed. Okay, so all these are performed through if you are arranging the reviews. Next one, captured rationale. The name is implies here. We are identify how much of quality attributes are we are already achieved. And another one, fourth one, here we are identifying the errors. So that means when we are developing some software, so before releasing the software to the end users, we should be performing some testing. In that testing phase, here we are observe so many errors. So maybe these type of if these errors are faced from the, or maybe if these errors are raised from the end users, that will be maybe the chance of degrading the performance of the software architecture. So that's why we try to examine the developed architecture and try to identify the errors, at the same time try to correct the errors. So those are 4 and 5 steps. And the sixth one is, so when we are correcting all errors and when we are able to reach the desired goals or maybe the requirements of the user, so that step completely will be related with the sixth step. So that means improved architecture. So that means up to now what we are observing. So those type of errors are recovered in the sixth step. Okay. So all these are we are already discussed, and here when we are performing the evaluation of the architecture, we should be based upon to the some properties also. So those type of properties are definitely the programmers or maybe the software developers or maybe the software architects. They may be having the clearly articulated goals and requirements for the architecture. So that means before developing the software architecture, those members having the clear idea. So what type of requirements are needed to achieve that type of the quality or maybe to achieve that type of the goal. Okay, so another one is the control scope. The name is implies here we are controlling the scope. For example, in some type of situations, maybe it will be leads to the out of the range also. So that's why here architects or maybe the developers need to verify so whether it will be maintained within the scope or not. Otherwise, it will be creates a lot of problems here. In some type of situations, maybe leads a lot of time, maybe needs a lot of members, maybe leads a lot of wastage of the money. Okay, and another one is the cost effectiveness, and another one is the key personal availability. Here mainly we are focused on to the how we are providing the security in this software. So that is the also one of the main property. We also know about that. So here we are discussing in the last classes, we are discussing different types of qualities. So those are nothing but software system software qualities, business qualities, and another one is the architectural qualities. So when we are using some software, definitely we will consider some of the properties. Those are what is the reliability, what is the performance, what is the throughput, okay, what is the responsiveness, and what is the architecture, how it will be interacted with the users, whether it is maintain the easier interaction or not. So all these are we are verified, and we try to suggest to our friends also. So this is the best software to solving your problems. So when we are giving that type of the announcement to our friends, so if the architecture is very good, and if that architecture is maintains the easier interaction with the end users, am I right or not? So at the same time it will be maintains the security also. So and another one is the competitive evaluation. So that means here we are verifying whether this developed architecture is able to release in the competitive environment or not. That will be also verified by to the architects. And another one is the managed expectations. The name is implies here what we are having the expectations before developing the software. So those type of expectations should be reached when we are delivered to the end users. Okay, so these are the main properties to evaluating the architectures, software architectures. And one of the best method is using ATAM. The name is implies architecture trade-off analysis method is used for to evaluating the software architecture efficiently. So in the last class we are already discussing about to this. In the case of ATAM, maintains the three groups: evaluation team, project decision makers, architecture stakeholders. So these three groups are used for to performing the evaluation and try to correcting the errors which are occurred in the software architecture. Okay. So in the case of evaluation team, here we are considered 4 to 5 people. In the project decision makers, here we are considered project manager, customer, and architect. Architects, stakeholders, maybe those are which members are directly interacted with the software. So those members are referred as a stakeholder. And another thing is here we are using three phases. So those are 0 phase, 1 phase, 2 phase, 3 phase. So when we are following the ATM, definitely we will be achieve these type of outputs. So that means we will be able to produce a concise presentation of the architecture. At the same time, we are able to define whatever it may we are specifying the goals, quality requirements, and mapping the architectural decisions to quality requirements. So that means by using ATM, we can able to identify the errors in a software architecture. At the same time, so those type of errors are we will be able to recorrect, and we try to map the architectural decisions to quality requirements. So that means so what we are specified before developing that software, those type of quality requirements are mapped through using the architectural decisions here. Okay, so the all these are possible through using the ATM, and here we are able to having some idea about so whether we are in the risk stage or maybe the non-risk stage. So if it is a risk stage, we are not performing the planned evaluation in the efficient way. If it is a non-risk, that is a good software architecture. Okay. So these are the outputs when we are based about the ATM. And another thing here we are using types of phases. What are the zero phase, one phase, two phase, three phase? In the case of zero phase, we are maintaining the partnership and preparation. In the one phase, yeah, one and two phases are used for to performing the evaluation. Third phase performing the follow-up. Okay, if you are observing these steps clearly, phase zero used for partnership and preparation, phase 1 and 2 performing the evaluation, and phase 3 performing the follow-up. Phase 1 having the 6 steps and phase 2 having the three steps. So these 9 steps are used for to performing the evaluation. What are they? Present the ATM process, present the business drivers, present the architecture, identify the architectural approaches, generate the quality attributes, and analyze the architectural approaches. So that means all these phases are used for to performing the evaluation. So that means initially we are consider the ATM, next we are consider the business issues, next we are consider what is the actual position of architecture, next we are consider which type of approaches are used for to reach the quality attributes, and another thing how we try to performing the analyze the architectural approach here. So these 6 steps are used for to performing the evaluation. In the case of quality attributes, we are already discussing about the quality attributes, different types of quality attributes. So here we are consider only some of them: performance, usability, availability. So all these are verified here. And another thing, this is the architectural approach analysis. So that means what we are considered. So how many number of modules are there? How many number of systems are used? So what is the performance? What is the reliability? What is the security? So all these things are verified into in the 6th step. And in the case of phase 2 also we are using 3 steps. Those are brainstorm and prioritize scenarios. So that means before delivering the software to the end users, so here we are using this step. So the brainstorm and prioritize scenarios are used for to giving some priority for some particular statements which are discussed between the software developers. So and analyze the architectural approach and present the results. So these are used for to submit the successful software architecture to the end users. Okay, up to now just only we are discussing about the ATAM. Now we are discussing about the CBAM. CBAM means cost benefit analysis method. So I think all these topics are we are discussed in the last class. I hope you are already understand all these topics. Just I try to revise what we are discussed in the last class. So the name is implies what is the purpose of CBAM, cost and benefit analysis method. So that means in the case of ATM, so just only it will be performing the architecture evaluation, but it should not verify, able to identify how much of benefit is we are getting after deliver the software to the end users or maybe the some particular organization. So here in this method mainly we are focused on to the how much of investment is used for to developing this project and how much of benefit is we are getting from the how much of benefit is getting from the software architecture. Okay, so those things are here verified into the CBAM. That is the main difference from the ATM. Here in the decision making contest, here if you are observing this diagram, we are mainly focused onto the business goals. So that means what is the meaning of business goals or maybe the business requirements or maybe the business qualities. So in the case of business qualities, here we are having some schedule in how many days we are able to release that product or maybe they release that software in the real-time environment. At the same time, how much of benefit is we are able to getting after releasing the software in the entire environment. So all these are the goals, business goals, and architectural strategies. Which type of strategies are here? We are used to achieve our desired qualities, or maybe desired goals, or maybe the desired end user needs. So how much of cost is we are using to achieving the those type of qualities. And here we are what we are verifying here. So that is performance, security, modifiability, usability. Okay, so all these are the important attributes. So actually we are considered so many attributes here in the case of quality, but here just we list of the some of the which are important only. And the last one is here we are trying to identify the benefit. So after applying all these concepts, so how much of benefit is we are we are achieved. So that will be clearly specified by using the CBAM. Okay. So and here we are using basics for the CBAM is here we are using different types of the utility curves. So based upon those utility curves, we are able to identify how much of benefit is we are getting from this. So that means if you are observing this diagram, so quality attribute response. So based upon that response, so that means here we are consider different types of the utility curves responses. So I also know about three things. Those are nothing but the first one is the stimulus, and the second one is the environment, and third one is the response. What is the meaning of response? After deliver the software to the end user or maybe the organization, it will be giving some rating. How much of it will be giving the satisfaction, or maybe the how much of it will be giving the or reach to the user needs. So that type of measure will be referred as a response here. If you are observing in this diagram, we are observed so many types of the curves. So these curves are used for to collecting the scenarios. These scenarios are used for to performing the reconstructing the architecture. So implementing the CBM process flow diagram. So how we are implementing the CBM. So that means if you are observing this diagram, so first of all, cut the scenarios and next refine the scenarios, next prioritize the scenarios, next assign utility, next develop architectural strategies for scenarios and determine quality attribute response level, and determine the expected utility value of the architecture strategy using interpolation, and calculate the total benefit obtained from an architectural strategy. And the last one is choose the architectural strategies based on return on investment subject to constraint. So if it is satisfied, we can stop the process. Otherwise, we are repeating the same procedure. So that means initially we are collecting some scenarios. So that means based upon these different types of utility responses, we are collecting some scenarios. Those type of scenarios are used for to correcting the software development architecture. Okay, so that type of correction will be referred as refined scenarios, and here we are assigning some priorities between them, and here we are assigning utilities. So what is the meaning of utility? Means to solving that problem which is raised in that particular architecture, and develop an architecture strategies for scenarios and determine the quality attribute response level. So that means here we are observing the quality attributes level. So how much of quality attributes we are achieved. So that means status. For example, maybe our goal is we reach to the 80%. So maybe in this test, we are maybe able to reach only 60%. Now, how we are able to recover remaining 20%? Determine the expected utility value of the architecture strategy using interpolation. So that means we need to include some other things to achieve our goals. And finally, we are calculating our benefit. So this is the main difference from the ADM. Actually, these two are performing the same thing, and these two methods are performing the evaluation in the efficient type of way. I hope I'm audible to everyone. At the same time, my screen is visible to all of the members. Am I right or not? Am I right or not? Am I right or not? Please respond anyone through chat box or maybe.
Yes, sir.
Okay, sir. Okay. Thank you, sir. Okay. So now we are going to the actual topic today. Please wait.
Ready? తిరుగు.
Okay. Hello. Srinivas sir.
సార్ చెప్పండి సార్.
What's the topic now on the screen, sir?
Moving from one system to many.
Okay, sir. Okay. Thank you, sir.
Okay.
Okay. This is the second part of the second unit. So in this, the here main topic is in the case of second unit. First, what is the first topic? Analyzing architectures. In the case of analyzing architectures, we are discussing about three topics. So architecture evaluation and architectural decision making, and another one is the ADM and CBM. Now we are discussing the new topic, that is moving from one system to many. So I think the name is implies here, moving from one system to many. So that means here we are increasing our throughput. We also know the difference between what is the throughput and what is the output. So what is the meaning of throughput? So how many number of outputs are generated within the time? So for example, maybe in this year, how many number of students are passed? At the same time, we try to verify the next year also, the same subject, how many number of students are passed in that exam. So that means equal period between them. And here we are identify, so how many number of outputs generated within the particular period of time. So that will be referred as a throughput. So that means the name is implies here we are increasing the throughput. So first of all, we try to see this. Focus on the construction of multiple systems from that architecture, discussing and giving examples of the system product lines. So that means here we are mainly focused on to the multiple systems. So why we need to base upon to the multiple systems means those are maybe having different types of advantages. We also know about different types of the operating systems. So parallel operating system, distributed operating system, am I right or not? In the case of parallel operating system, more than one CPU is used for to performing the same task, or maybe the to performing more number of tasks at a time, but they are based upon to the single shared memory. But in the case of distributed operating system, we are using the same thing, but here we are maintain the individual memories with the individual CPUs, and all these are able to performing the sharing between them and able to share the work and try to complete the work within the time and increasing the productivity. So in the same way here also we are using the same concept. So that is we are mainly based upon the 5 perspectives. So those are the first perspective is based upon the technology. So that of the technology underlying the product line, that of the single company that build a product line, a naval vessel fire control systems, that of industry wide architecture, that of a single company producing product based on the industry wide architecture, that of organization building systems from the commercial components. So that means here based upon the 5 perspectives, we are using more than one or maybe the multiple systems. So those are nothing but the first one is to maintain the increasing the technology and wide the architecture and increasing the productivity and able to that of the organization building systems from commercial components. So these are the perspectives using multiple systems. Okay, next here we are mainly based upon to our first topic is software product lines. Okay, so I think the name is implies here we are using some type of lines. So those lines or maybe those type of paths are used for generating the software products. So that means here we are discussing about how we are using those type of paths. Okay, here if you are observing this, reusing the architectural assets, the name is implies. Here we are using the reusing architectural assets. So what are the architectural assets actually? So that means any type of the software architecture needs some of the things. So we also know about that requirement analysis and design, coding, testing, maintenance. All these are the requirements to develop the some particular software. Am I right or not? So these are the architectural assets. Now we are using the reusing the architectural assets. So that means here we are reducing the time. For example, maybe if we are developing the software for to the one college, for example, our college. So now we are already developing some software for to the our college. So for example, if any other college is responded, so you please to make another software for my college also. Then we can using the same procedure to develop the software for another college also. So that means here the we are hello 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 hello. So please mute yourself first. Don't try to create the disturbance. Number 44, 57, 14, 28, 35, 50, 61. So why you are not mute yourself? All of you please mute yourself first. Otherwise I will remove from the group. Try to make it fast. Srinivas sir.
చెప్పండి.
If any member is not using the mute, you can remove that person from the group, sir. Why? Because
Okay,
those
sir.
members
Okay.
creating some disturbance.
Okay, sir.
Try to giving some chance.
Okay, sir. Okay, sir.
All of the members, please using mute. Don't try to create any type of the disturbance. Okay. Thank you. I will continue my session now. Okay. So here we are reusing the software architecture assets. A software architecture represents a significant instant of time and effort, usually be senior talent. So it's natural to want to maximize the return on this investment by reusing an architecture across multiple systems. I think the name is implies why we are increasing the one system to more systems. Why? Because to develop more than one software at the same time, we can develop the same software within the time and maybe increasing the time and increasing the throughput. So for this purpose, we are using the same, reusing the architectural assets. So that means here we are maximizing the return on investment. We also discussing about this word ROI, return on investment. So that means, so we are what we are expecting after investing on the particular software architecture. So that is nothing but return on investment. So that means here we are increasing our throughput by using using this. Organizations tend to treat their architectures as valuable intellectual property and look for ways in the what the property can be leveraged to produce additional revenue and reduce the cost. Both are possible with the architecture reuse. So that means when we are reusing the architecture, then we are having the reducing the costs to developing that software. Okay, so that means the same type of the architecture is used for be able to develop more than one software architectures. At this time of situation, here we are increasing the productivity at the same time decreasing the cost to making the softwares. So so that means here we are achieving some type of the benefits, or maybe we are achieving some profits when we are reusing the architectures. Okay, so software product lines based on the inter-product commonality represent an innovative growing concept in a software engineering. So that means before developing the software for any type of the organization or maybe the any type of the user, first of all verifying which are the common things. So if the things are common, then we are easily developing the software. For example, maybe if the 20 organizations, if the 20 organizations or maybe 20 colleges asking to develop some software or maybe to performing some automation in our college, so then obviously all the colleges having the same type of the manner, all the colleges having the students, all the students having the exams, all the students having the marks. Am I right or not? So that means if we are developing only one architecture, so that will be able to use it for more than one, more than one in organizations. Am I right or not? So that means reducing the cost but increasing the productivity when we are reusing the architectural assets. So that is mentioned here. Software product lines based on the inter-product commonality represent an innovative growing concept in a software engineering. Every customer has its own requirements which demand flexibility on the part of the manufacturers. So obviously any type of the customer or maybe the any type of the user having the some requirements. So my software is working like this. So and you try to provide the securities like this. So no, we are not able to allow unauthorized persons to access our software. So like this, whatever it may be. Software product lines simplify the creation of systems built specifically for the particular customers and customer groups. So that means here we are observing the common things to developing the software. So for example, if it is related to the to developing some other software, so here try to reducing the cost to making the software. Why? Because just only we are performing edit operation only. Am I right or not? So what makes software product lines work? The essence of a software product lines is the disciplined, strategic reuse of assets in producing a family of products. Hello. Excuse me, 1 minute.
Sir, Ganesh sir.
Yeah, sir.
Okay, sir. Carry on, sir.
Actually, here I'm facing one problem, so that's why. Okay.
Okay.
What makes software product lines work? So the essence of a software product lines is the disciplined strategic reuse of assets in producing a family of products. So that means here, so the main use of software product lines is able to maintain the some type of systematic ways for reusing the assets to producing the family of the products. What makes product lines succeed to so spectacularly from the vendor or developer's point of view, that the commonalities shared by the products can be exploited through reuse to achieve the production economies. So that means here we are using less cost to develop more than one software architecture. The potential for reuse is broad and for ranging, including so which type of things are we are consider, or maybe which type of things are reuse in the software architecture. So those are the first one is requirements reuse. Requirement the time to developing the software and underlying the architectural design. For example, maybe if it is a college or maybe if it is a arm of the particular business. So maybe some businesses are similar. Maybe some type of colleges are similar. So in the same way, when we are based upon to the similar type of the software architectures, then reducing the time to developing that software and reducing the cost. Why? Because here we are reusing the architectural assets. So in that one here, maybe we are need not to wait for, or maybe need not using a lot of time to collecting the requirements. And second thing is architectural design. We try to follow the same design. So in the previous case, what type of design is followed to be developing that architecture? In the same way, here also we are using the same type of the design. Yeah, architecture for a software system represents a large investment of time from the organization's most talented engineers. So as we have seen that the quality of the goals for a system, performance, reliability, modifiability, and so forth, largely allowed for precluded once the architecture is placed. So that means here, so before designing any type of the software architecture, we should be include some of the qualities. Am I right or not? So if those type of qualities are able to getting after developing the software, so those type of things are should be included into the design also. So the type of the time is also reduced. If the architecture is wrong, the system cannot be saved for a new product. However, this important design step is already done, need not to be repeated. So that means, for example, if the architecture is correct, then we try to follow blindly here. So and reducing the time to developing the software. And we are based upon to the elements also. What is the element? Software elements are applicable across individual products. For and above more code reuse includes the often difficult initial design work. Design success are captured and reused. Design dead ends are avoided, not repeated. So that means here, so for example, if those type of architectures having the similarities, then we try to follow the reusing the same elements. And in some type of situations, maybe we are facing the problems also. So those type of problems are here easily observed, and those type of which are creating the problems, those type of things are not repeated. This includes the design of the elements interface, its documentation, its test plans and procedures, and any models used to predict or measure its behavior. So that means we are able to easily performing the prediction also. So we also know about which type of problems are we are faced. So if we are following that type of the strategy, am I right or not? Why? Because here we are developing the similar type of the architectures. So one reusable set of elements is the system's user interface, which represents an enormous and vital set of design decisions. So that means here we are providing different types of interfaces. So which are easily interacted with the user. Those type of interfaces are included in the design in the developed software architecture. Modeling and analysis, performance models, schedulability analysis, distributed system issues, such as proving the absence of deadlock. We also know about what is a deadlock. What is a deadlock? I think the name is implies here. We are providing some lock to whenever any one of the process is not able to execute its execution. So at that time of the situation, maybe we are able to refer to it is a deadlock. So we also know about what is a deadlock, and whenever the deadlock situation is also occurred. So that means whenever resourcing, whenever shared resource is not available to share it between the more than one process. At the time of the situation, maybe the chance of happening the deadlock. So we also know about the conditions. What are the conditions to occurring the deadlock? So what are the conditions? Mutual exclusion, no preemption, and circle wait, and when hold and wait. Am I right? Am I right or not? So if these four types of conditions are happened, then we can clearly declare it is a deadlock. So that means when we are based upon to the more than one system, definitely we will consider all these things. Okay, performance models, schedulability, analysis, distributed systems, issues, allocation of process to process, fault tolerance schemes, and network load policies all carry over from product to product. Okay, Celsius Tech supports that one of the major headaches associated with the real-time distributed systems, it rebuilds has all but vanished. So that means we also know about the distributed system also. What is a distributed system? So when we are using individual memories with the more than one CPU to perform in the same task, or maybe able to handle the more than one task. So that will be referred as a distributed system at this time of situation. So increasing the productivity, at the same time not occurring the chances of deadlocks also. Why? Because here for initially we are verify whether those any type of the shared resource or not. So that means first of all we are verifying how many number of resources are shared by more than one CPU. So that's why that type of the analysis is used for reducing the occurrence of the deadlock. So when fielding a new product in the product line, it has extremely high confidence that the timing problems have been worked out and the bugs associated with the distributed computing, synchronization, network loading, deadlock have been eliminated. So that means, so when we are work with distributed system, so we should be consider the synchronization and network loading and deadlocks are occurred or not. So that means what is the meaning of synchronization? Synchronization means those type of modules are interconnected to one to another and able to respond at the same time. So that means when we are for example, maybe if we are synchronization means we are providing some cooperation. Okay, and another one is here verifying the network loading and deadlocks also. So another one is the testing. Test plans, test process, test cases, test data, test hardness, and the communication paths are required to report and fix problems are already in place. So that means testing is also one of the uh, phase to developing the software, and this is also one of the architectural asset. Project planning, budgeting, and scheduling are more predictable because experience is high fidelity indicator of the future performance. So that means here, so when we are developing similar type of the architectures, these types of steps are reducing the time to developing the software. Am I right or not? For example, we also know about which type of requirements are gathered and in which type of we are able to design, and in which way each type of we are able to performing the testing, and in which type of way we are able to achieving our qualities, and in which type of way we are able to recover the errors, like maybe the network loading errors or maybe the deadlocks. So whatever it may be. So that means here we are easily performing the forecasting, and it will be reducing the time to recover the errors also. Why? Because the same type of errors are also in the previous case also we are solving it efficiently. So that's why here reducing the time to developing the software. So that means automatically increasing the throughput. Okay, work breakdown structures need not be invented each time. Teams, team sizes, and team compositions are all easily determined. So process methods and tools. So that means configuration, control procedures and facilities, documentation plans and approval process, tool environments, system generation and distribution procedures, coding standards, and many other day-to-day engineering. So that means all these are also similar. So which type of process are used, which type of methods are used, which type of tools are used to developing those type of architectures. So in some type of situations, maybe we are using taking some new decisions also. Why? Because in the previous case we are using some the particular type of the strategy, so that is not achieving the maybe desired quality. So we try to including some other innovative development. So that means here architects may be having the chance to create at the same time able to release the good quality of the software architecture and within the less time. That is the most important. Why? Because here the time is always related with the money. Am I right or not? For example, if the time is increased, then automatically persons are increased. Then automatically amount is also increased. Then automatically degrades the performance also. Why? Because if you are not developed within the time, so there then we are not able to done the market in the efficient way. So automatically degrade the performance of the software architecture. Okay, just give you 1 minute, please. Okay, thank you. Okay. Uh, so all these are the nothing but all these are the we are able to reuse the architecture assets. Up to now we are discussing modeling analysis, and another one is the testing, project planning, and process methods and tools. Okay, the overall software development process is in place and it has been used before. Pupil, because of the commonality of the applications, personnel can be fluidity transferred among the projects as required. Their expertise is applicable across the entire line. Exemplar systems. Deployed products serve as a high quality demonstration prototypes as well as high quality engineering models of performance, security, safety, and reliability. So that means here architects may be having the idea which type of things are need to be included and which type of things are need not to be included. And defect elimination. Product lines enhance the quality because each new system takes the advantages of defect elimination in its forebears. Developer and customer confidence both rise with each new installation. The more complicated the system, the higher the payoff solving vexing performance, distribution, reliability, and other engineering issues once for the entire family. So that means here we are easily developing the software within the time and able to performing the testing within the time and able to correcting the errors within the time and able to avoid unnecessary things to developing the software, and automatically we are increase the quality of the software development architecture. Okay, all these are possible through increasing the productivity through reusing the architecture assets. So another topic is scoping. The name is in place. What is the scope? The scope of product line defines what systems are in it and what systems are out. So that means why we are using the scope. So we try to know about the border, whether we are in the border or maybe out of the border, whether we are within the plan or maybe without out of the plan. So that will be identified by using the scoping. Put less bluntly, a product line scope is a statement about what systems an organization is willing to build a part of its line and what systems it is not willing to be built. So that means which is able to willing build and which is not able to willing to build. So that will be identified by using the scoping. Defining a product line scope like a drawing donut in the space of all possible systems as shown in figure. The donuts in the center represents the systems organization would build because they fall within this product line capability. Systems outside the donut are out of the scope once the product line is not well equipped to handle. So that means, so here we are observing some scope. So that is through donuts here. If donut is out of the scope, so which is inside of the donut, so that will be considered and that is the best plan. Okay, systems on the donut itself could be handled, but with some effort and require case by case decomposition there is. So if you are observe this diagram, scope of the product line, I hope all of the members able to see the screen now. Okay, so this is the scope of the product line. So which is inside the donut, so that will be considered. So which is outside of the border. Hello, hello. Hello, hello, please. Hello, mute yourself first.
సార్ చెప్పండి.
Oh, okay, sir. Okay. So here we are discussing about the scope of the product line. Okay, and another one is the architecture for the product lines. So of all these assets in a core assets repository, the software architecture plays the most important central role. So that means here how we are using these product lines for the architectures. The essence of the building a successful software product line is discriminating between what is expected to remain constant across all family members and what is expected to vary. So that means if you are using these product lines in the efficient type of way to reusing the architecture, then we are increasing upon to the product lines. Here are the mixture of things, identifying variation points, supporting variation point, and even architecture for product line suitability. I think these topics are we are discussed in the next class. Why? Because just we are having only 2 minutes. So up to now, just we are revising what we discussed in the last classes. So that is first of all, how to we are performing the architecture evaluation, and second thing, how we are using the ATM and what are the phases of the ATM and what are the groups of the ATM, and another one is the CBM. What is the difference from the ATM, and which type of steps are followed into the CBM. So I think the name is implied. So these are the important questions from this unit. So you try to remember all these topics easily, I think. Why? Because here the main concept or the main intention of this subject is, so how to we are design the software architectures, and how to we are maintain the easier interactions with the users. So why? Because here in some type of situation, some of the softwares increasing the ambiguity, or maybe increasing the toughness or complexity in front of the or in terms of the end users. So that's why all these approaches are used for reducing the complexity. So in the first unit we are discussing about which type of quality attributes are maintained and how we are maintaining those type of quality attributes. In the second unit, how we are performing the evaluation, whether we are able to achieve those type of qualities or not. So in this today we are discussing about to the, so how to move from one system to many. So that means here we are discussing about software product lines. So how the we are able to increasing the productivity and how we are able to reducing the cost. So those things are we are discussed in the next class. We are discussing about the same topic, and we try to complete the second unit within the next classes. If any member is having any doubt about the doubt, you can please mute yourself and ask me. Otherwise, we can end the session. Srinivas sir,
Sir,
sir, are you taking the attendance, sir?
yes, sir.
Okay, sir. Okay. My close the session, sir. My close my session, sir. I hope I'm audible to everyone. At the same time, whatever it may be, I'm discussed up to now. All these topics are understandable by to you. So, okay. Thank you, everyone. We will meet again on the Monday. Okay.